So today what we're doing is factoring. We've done factoring. The test I handed you guys back, that had a lot of factoring in it. Okay, so luckily a lot of the steps that we use today are going to be steps you've used before. Okay, on the board here I have some directions. I have the same directions on your paper. They're just on the back side of it. Okay, so they're steps that we've used before, especially the trinomial one. Trinomial steps, they should look familiar. Maybe not the last step. The last step's new. We're going to see some binomials. Binomials are two terms. We haven't factored those yet. That's kind of the new stuff, part of the new stuff. Okay, so one of the ways we can factor binomials is called difference of squares. Okay, difference of squares only happen with binomials, and it happens when both of the terms are perfect squares. Are perfect squares. So when I say perfect squares, what is a perfect square? What is a perfect square?
Square root that's a whole number.
There you go. Square root that has a whole number. So what's the let me make a list here. What's the first perfect square? Even before that, there's one. One, yeah, one is a perfect square because what's the square root of one? One. One times one is one, right? It's got a nice, pretty number. Doesn't have a long decimal, right? So what would be the next perfect square? What would be the next perfect square? 4. Because it's 2 times 2, right? And the square root of 4 is 2, right? What would be the next one? 9, right? Because it's 3 times 3. Kind of get the pattern right. Then 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and it keeps going and going and going. It never stops, right? So 1 is a perfect square because it's 1 times 1. 4 because it's 2 times 2. 9 because it's 3 times 3. 16 because it's 4 times 4. 5 times 5. 6 times 6. 7 times 7, so on and so forth. So all of these guys right here are perfect squares. The list continues, but we stop there, right? So that's what I'm looking for. I'm looking for those numbers here and here. Okay? So the first example, x squared minus 9. Does it have a perfect square in the front? Yeah, what is the number? 1, yeah. 1's a perfect square. It was on my list, right? How about the second number? 9. Is 9 on my list? Yeah, it's on my list too. And that's the square part, squares. The difference part is the subtraction sign in between them, right? There's a subtraction sign in between them. Has to be a subtraction. That's why it's called difference of squares, okay? So if that happens, right, if that happens, we have two terms. I got an A term and I got a B term, right? The first term is called A, the second term is called B. So A would be 1, right? And then X, right? What would the B term be? 3, yeah, because 3 squared makes 9. So if we have an A and a B that fits, we use the rest. I have 2, they factor to make A plus B, so 1x plus 3 and 1x minus 3. Okay, and that's how they factor. It's a quicker way of factoring if we can, but that's not always going to be the case. There won't always be difference of squares, but if there are, we use that. If you can use that. Okay, so let's look at B. Let's look at B. Is B an example of difference of squares? So two things have to happen. You have to have two numbers on my list, and there has to be a subtraction in the middle. That's the case, right? So we're going to have a plus and we're going to have a minus. So what is the A term? What squared? What would go in the first set of parentheses? 5x, right? Because the square root of 5, or 25 is 5, and then the square root of x squared is just x. What would go in the second set of parentheses? 9. So it's going to be 5x plus 9 and 5x minus 9. Okay. All right. So let's look at letter C. 4 and 21 are on my list, right? 4 and 21 are on my list. We're good there. But the problem is the power here, right? The power is not squared anymore. It is to the 6th. So 4, I can put 2 here. And 121, I can put 11, right? That works. But what do I need to put inside? X to the what? How can I make that work? How can I, what x to what power would make 6? 3. Right? So now my A term is 2x to the 3rd power. My B term is 11. So I rewrite it just like I did the last one. A plus B, A minus B. Okay. The last one. Well, first it's out of order, right? It's not in standard form. The power needs to come first. So the first thing I need to do is a switcheroo. First thing I need to do is switch it up. Okay. And then you look at it and you're like, that kind of looks like difference of squares, right? 64 is on my list and 1 is on my list. But what's wrong about it right now? What's wrong? So what's not right about it, I should say? Yeah, there's an addition sign in between them, right? And there's actually a negative in front. So it's not 64, it's negative 64. And negative 64 is not on my list. But is there a way I can I factor out a GCF so that it would make it positive 64 and a minus sign in between? What GCF could I divide by? See, I could, if I divide by 8 or negative 8, I would have to divide both, right? And what happens is that becomes negative 8 or positive 8, right? And that 8's not on my list. So I want to keep 64 and 1 because they're on my list. I just want to change the signs. So when you want to change the signs, what do you want to divide by? Negative 1, yeah. Negative 1. So that makes positive 64 x squared minus 1. Now that looks more like something I want to use, right? A is 8x. B is 1 with the negative 1 in front. Don't forget about the GCF. If I have a GCF, I need to put it in front. Okay, so I have a negative 1 in front. And then I'm going to have 8x plus 1, 8x minus 1. Okay. That's what I mean by difference of squares. So you see on your steps, the last step is always difference of squares. Is there a relationship there? If there is, do what we just did. If there's not, we can skip it. Okay, so it's not, difference of squares is more of a math 2 thing. Today we're going to use it, but it's going to just be one of our steps. Okay, so I wasn't sure if you did that in math 2 or you remember it from math 2, so I wanted to go over it again. Okay, so we're going to use that. So remember, difference of squares has to be subtraction in the middle. There has to be subtraction in the middle for us to use difference of squares. If it's a plus, because you'll see something like this. X squared plus 16. You're like, yeah, 1's on my list. 16's on my list. But it's not difference of squares because it's not a difference, it's a plus. So you got to be careful. Okay, you got to be careful with those. This guy, I can't do difference of squares. This guy, I can't. Okay, so just be careful. All right, so let's go to the back now. Okay, so like I said, this part right here is new. The bottom part, not necessarily new. We've done it before. So factoring. Okay, so that's what we're doing today, factoring. If it's a trinomial, we're going to use the bottom steps. If it's a binomial, we're going to use the top steps. Okay. All right, so let's look at example number 2. This guy, oops, no, I don't want to do that. This guy right here. That kind of looks familiar. It kind of looks like stuff you did on the test last week, right? What's different about this guy here than the ones you did on the test? It's a trinomial. It's got 3 terms. But what's different about it? Something a little different about it than the one you did on the test. What's different? See if I can get some examples here. I'm really scrolling back here. Kind of looks like that guy, right? This one we did like a month ago. What's the difference between that guy and that guy? Besides the numbers, I know 2 and negative 24 and 2 and negative 15. What's the difference? Powers are different, right? What's different about the powers? They are bigger here, right? It's kind of like amped up, right? They're kind of like it's on steroids. It's amped up a little more, right? Than this guy here. That's what it is. They're just amped up. That's all. We treat them the same way. We treat them the same way. They're called higher order, higher degree, right? That's what we do in Math 3. We work with higher degree stuff, but we use the same tricks that you used last year, Math 2, last chapter in this class. We use the same tricks, right? If it's a trinomial, we have our steps. We have our 5 steps, right? We're going to use those same 5 steps. First step says, get the equation equal to 0. Put it in standard form. Well, there is no equation, right? There's no equal sign. Skip that step. Is it in standard form? Or do I need to rearrange things? Is it in standard form already, or do I need to rearrange things? It's in standard form, right? It goes from, it's missing some powers, but it goes in order from biggest power to lowest power. So we can skip step 1. Step 2 says factor out a GCF. Is there a GCF between the 3 terms? No GCF. So we can skip that step. Make sure the leading term is positive. Yep, it's positive. The 1 in front of x squared, x to the 4th is positive. So our next step says ABC. So let's do ABC. We get A is 1, B is 2, C is negative 15. Okay. A times C, negative 15. B is 2. Okay. So the two numbers that multiply to be negative 15 but add up to be 2. 5 and negative 3. All right, so then we move to the box. Okay, so my focus is on the green now. So the first term is going to go up here, just like always. The last term is going to go down here. 5 is going to go here, and negative 3 are going to go here. Just like always, right? But before, last chapter, they just had an x with them, right? Here, they need an x squared, because when I add them together, they have to make this term here. So they'll make the 2, but they will need an x squared for me to make 2x squared. So I put an x squared with them. Okay. So they do the same game. What times what makes x to the 4th? What times what makes x to the 4th? X squared, yeah. X squared and x squared. Absolutely. Okay. So I have an x squared here already. So over here, I need a plus 5. And over here, I need a minus 3. Okay. Let's move those out. X squared minus 3, x squared plus 5. No GCF, so I don't have to put it in the front. Here's where my last step comes in. Are any of these guys difference of squares? Let's start with the first guy. This guy right here. X squared minus 3. Is that difference of squares? No. Yeah, what part about it makes it not difference of squares? 3. Yeah, it's got the squared. Oops. It's got the minus, but 3 is not on my list. Okay. How about this guy? No, definitely not this guy, right? 5's not on my list, and it's got a plus. So we don't need to do that step. We are done. Okay. So when you put it in a delta math, one box, make sure you have the squared there. Because if you don't, sometimes I've seen some students just put x minus 3, x plus 5. That's not correct because you need the x squared. Okay, so don't forget about that x squared. All right, so let's go to number 3. Now this one has 2 terms. It's a binomial. Okay, it's a binomial. So we're going to use a different set of directions. Less steps. So that's kind of nice, right? First step are always the same. Set it equal to 0. Make sure it's in standard form. Okay. No 0, no equal to 0. It is in standard form, right? You got a 3, then 2. It goes in the order of powers. Check. Step 2. Factor out a GCF. Well, they do share a couple things in common. What do they share in common that I can divide out? X, right? How many do both have at least? They both have at least 2, so I can factor those out. And then it says right here, when I factor out a GCF, the leading term has to be positive. The leading term right now is negative. So what else do I need to divide by to make it positive? Negative 1. Yep, negative 1. So my GCF is going to be negative 1 x squared. Okay. Now I'm going to divide. Negative 1 goes into negative 2, 2 times. When we divide, we take away powers. So I'm taking away 2 powers. So that just leaves 1 power left. I took away 2 powers, so that leaves 1 power left. Negative 1 divided by negative 3 is positive 3. I took away all its powers. If I took away all its powers, it has none left. When you divide, you take away powers. When you multiply, you collect powers. Okay, so last step, difference of squares. is that one difference of squares, 2x plus 3? Nah, it's missing a lot. 2 and 3 aren't my list. And it doesn't even have a square. It doesn't even have a minus. So we're done. That's as far as I can factor it. Okay. All right, so I want you to do number 4 right now. I want you to try number 4. It's a trinomial, so use the trinomial steps to do number 4. I'll let you work on that for a few minutes, and then we'll do it together. All right, so yeah, so it's a trinomial. So we're going to use the trinomial steps. So step 1, set it equal to 0 if it has an equal sign, and put it in standard form. So it's a little bit out of whack right now. I got to put this term in front of the front term. So it's actually should be like this: x to the 5th minus 7x to the 3rd plus 6. Signs stay the same. I just shuffle some things around. That's step 1. Step 2, factor out a GCF. They do all have a GCF. Not a number, just a letter. They all have at least 1 power of x. Okay, so that leaves x to the 4th, set negative 7x squared, and positive 6. So now my focus is here. That's what I'm going to be working on for the next several steps. Okay. Next step. Okay, leading term is positive. Yes, we're good there. A, B, C. A equals, B equals, C equals 1, negative 7, positive 6. What are the two numbers that multiply to be 6 and add up to be negative 7? There you go. All right. So let me move to the box. So the first term in the green is x to the 4th. The last term is positive 6. I had a negative 1x squared and a negative 6x squared, because together they have to make this negative 7x squared. So when I combine these guys, that's what they have to make. Okay. X squared to make x to the 4th. And then I need a negative 1 here and a negative 6 here. So I have x squared minus 1, x squared minus 6, and then I had the GCF. I can't forget about the GCF I had earlier, right? That was step 3 and 4. Step 5, are any of these guys difference of squares? So are any of these guys here that I just circled difference of squares? Give you a hint, one of them is. There you go. This guy in the middle. It's got a 1 in front. It's got a 1 at the end. It's squared and it's minus. Okay, so this guy here. So A is 1x. B is 1. So it's going to be x plus 1 and x minus 1. So I have the x in front. These two guys, and then this guy. 6 isn't on my list, so I don't need to worry about that. Okay, so that is completely factored. All right. Okay, so try number 5 now. Do number 5 right now. Okay, so number 5 is a binomial. Got 2 terms. So I got to follow the binomial steps. Less steps, just, but they're still important. So step 1, set the equation equal to 0 and make sure it's in standard form. Okay, let's see. No equal sign, it's in standard form. Check. Factor out a GCF. I can factor out a couple things here. You can divide them both by 4. And they both share 3 z's in common. So I can divide by z to the 3rd power. So that's my GCF, 4z to the 3rd power. So when I divide 4 divided by 4, it makes 1. And then when I divide powers, I take away powers. So I had 5, I take away 3, I have 2 powers left. 4 goes into negative 64, negative 16 times, and I took away all 3 powers. So it's nothing left. Okay. Last step, third step, are any of these difference of squares? Is this difference of squares? That one is. So when I break down that one, what is it going to be? Z plus 4 and z minus 4. Yeah, you can do z minus 4 and z plus 4 for it could be out of order. It's okay. There you go. Okay. All right, one more problem, we're done. One more and we're done. That's enough examples. You know, I won't give you any more to do in your notes. So I want you to try this one. Try this last one on your own. It's kind of like number 4. Okay, so it's a trinomial, so I got to use my trinomial steps. I have to put it in standard form. Factor out a GCF. Yep, they do have a GCF. They all can be divided by x. X to the 4th, 2x squared, minus 24. Okay. All right, so now I got to focus on the green now. The green factored out to GCF. Now I got to do ABC. ABC says 1, 2, negative 24. The two numbers that make negative 24 and add up to be 2, 6 and negative 4. So I get x to the 4th, negative 24, 6x squared, and negative 4x squared, because together they have to add up to the middle, to that term right there. So that's why they have x squareds with them. Okay, so to make x to the 4th, I go x squared and x squared. And then this one needs a positive 6, this one needs a negative 4. So I have x squared plus 6, x squared minus 4, and then I had a GCF as well. So I got to include that too. Last step says, are any of those difference of squares? Are any of these guys difference of squares? The answer is yes. This one is right there. Because 1x and 2 squared. So it's going to be x squared plus 6, x plus 2, x minus 2. So it breaks down pretty far. Bless you. Bless you. Okay. That's it. All right. So tomorrow we'll do some practice. Today, tape in your notebooks. And yeah, that's about it. Okay.